Here's what a bad cam phaser sounds like on an '08 CTS, direct injection, 3.6 liter. So that sounded pretty horrifying, yes? So after doing the timing chain process, the engine ran perfect, no check engine light, and this is 6 months later. I had a new issue. I had went to a strip mall, went into one of the shops, came out, started the car, running perfect, AC was on, and when I came to the first stop sign, I felt a small thud, a slight jolt. And I thought, is the car running? Looked at the tachometer, it was at 0. So I said, okay. Went to start it, it cranked over, it was trying to start but would not start. So I waited another minute, started to crank the engine over, it cranked over about 3 turns and shut off and wouldn't do anything more. So story short, I got towed home. My son found a blown fuse for the ECM. He replaced that fuse, started the engine, and it sounded like what you just heard. So I got a code reader. I was getting all kinds of codes, and it seemed like they were changing or adding to the codes on each start, and the engine sounded differently each time I started it, and it was really strange. At one point I did get timing chain codes for camshaft correlation with the crank, but I didn't pay a whole lot of attention to it because I didn't get it initially. It was in there at one time, and I knew I had done all this work. So then we cleared the codes and did it again. The crank correlation and cam did not come up, but there were other codes, multiple misfires on most every cylinder, through a code for low fuel pressure. And this is the direct injection, which has the high pressure fuel pump right there. So I thought that might be a culprit. But before just throwing a fuel pump on, I thought at minimal, I could take the intake off, valve covers off, and check right here. So before I removed the front cover, I had the valve cover off. And here's what I found. This chain was that loose. And then I moved this back and forth, and the pin that locks this was unlocked. You could move it. This one the same thing. So I moved it around a bit, and the pin popped back in. So it was back in time. The flats were up back here on the cam. To further investigate, I'm like, I need to remove this entire front cover. I want to see if my timing marks, chain, guides, and everything's good before I change these phasers. And all the timing marks are in check. So I'm going to change all 4 phasers due to the mileage on the vehicle. Suggestion, if you got over 100,000 miles and you're doing a timing chain and gear, change everything. So to get to this point, the teardown, you can reference my previous video on timing chain and gear replacement. And what you want to do is rotate the engine to stage 1 timing. 5 o'clock dot on the crank, oil pump, make sure your flats are up on the cams, and that puts the engine in a relaxed state. So when you remove the phaser, cams are not under tension and take off on you. So this is the driver's side, and on the driver's side they use the round dot for timing mark, and you want to mark right where that dot is on the phaser and the link. So when you put the new phaser on, you just line up that dot and that link and you're in time. Another way of doing it is you come over here to the circle dot. There's the dot, there's the L. You'll have, including this link, 12 links over will take you to here. So you can mark it or just do 12 over, provided everything's in time. This is an easier method. So the way I broke this bolt loose is I got these vice grip style crescent wrench on here and adjusted it and then clamped it, and then got a 5/8 socket and did one of these numbers, and it broke right loose. But before removing that, you want to release the tension on the chain. So I've got a carpenter's clamp, put it right in this hole, and I'm on the plastic, not necessarily the chain, so I don't damage the guide, and just clamped it on. Pull that tensioner in, remove the bolt. It just drops right down. Slip the chain off. And now we'll install the new phaser. And the new phaser looks a little bit different. And they speak about a thrust washer. So we'll look into that as well. So here's the front side, old, new. And I lined these up. And then I've got the dot highlighted. They look to be in the same position. The only thing different is the in is way over here and that dot is different. But the timing mark is what we're concerned about. And this is a newer style, so there's going to be some differences. Backside, this is a 5-bolt pattern, 4-bolt on the new, and the inner ring looks different. The locking pin for the cam looks the same. Let's open this up. So the first issue I ran into is these bolts are a Torx head, but it's a 5-point. So I had to purchase this set here. And it's a 27 5-point Torx, which is right here. And then the second problem is I stripped out a couple. And then I filed that down and still didn't work. So I put it in a vise and chiseled these out. It was spring loaded. And it loosened up when I removed the plate. I'm not worried about that because I got a new one. We just want to look at it. What we've got here is these vanes, they call them. And they got little metal springs that seal right between here. A couple of them already fell out. I've had this apart already. And then here's your locking pin right there. It's a little bit different size, so you can tell that's the one that locks. The pin is in the lock position right now. That's the way I took it off. And I'm going to remove this, unlock the pin here, remove the pin, show you the spring. There's a spring down here. And then show you the movement. So you just push down and it comes right off. And right here is the spring-loaded locking pin. Pull that out. And there's a little spring right there. Just pop it right out. There it goes. So it's gone forever. These just slide right up. So here's the 4 vanes. Then we have these little flex springs that seal in between the vanes. I lost a couple. Here's your spring that goes into this notch right here. So you compress the spring up against this side, push in and push down. So there's your spring in there. And then this has a little notch that goes around the spring, and then it's spring loaded. So when this pushes out, it locks into this groove. And that groove is larger than the others. The others take the vane. So what I'm going to do now is install everything without the locking pin to show you the movement. I'm going to line up that thicker notch with the locking pin notch. And this thing's tricky. It's tight. I don't know if that's supposed to be that tight, but I mean, that's another issue. This unit could be tight and not functioning correctly. The spring's weak. You got a spring here. Oh, there's also a spring here. There it is. That's spring loaded. That could also be weak. And that's what returns it to the locking position. Oil pressurizes it, advances it, and then this retards back to the lock position. Once you get on, then it spins nicely. So we'll bring it back around to the lock point. Fits right in there. You got their notches outward. Slides right in that little groove. Just like that. Now I'm not sure if this is correct, but I believe this little opening here would be the vane. And then this seals so the oil cannot escape. Now here's the variable timing right there. So if you want to go advanced, it fills up with oil behind this vane and pushes it that way. Then releases oil and puts pressure on this side if it wants to retard. Like that. So I'll put it on the car and let you see what that looks like. So let me redo that real quick. The sprocket is on backwards. Alright, so let me mark the timing dot. And we're in the lock position. So it's installed in the lock position, although the lock's been removed. Here's your timing mark, link to link, 12 links. Now I'll move the cam. There's your movement. The cam is free to do whatever it wants here. Of course, I'm limited in my push here. I can go further and further back the other way. I just don't have the room. But that's what's going on. And the mechanic told me, I took this to a mechanic. And he gave me a heads up. He says, what's happening is, when you go to start the car, these cams are in the wrong position. And that's how I found it. Even further than that. And he says, it's so far out of time here, this side of the bank cannot even ignite the spark plugs. And that's what I had with the last code. This entire bank was not firing. So it was running on 3 cylinders. And I had low power. And it didn't knock or anything. It just was not drivable. So I'll install the new cam and thrust washer. All 4 phasers, left and right, and then we got the thrust washer. This goes over the camshaft and sandwiched in between that and the phaser. Now one side is like raised, rounded a little bit, and the other side concaved. There was no instructions, so I'm going to put the raised edge against the cam cap. So if the cam walks, it won't gouge. According to Cody Smith, if your vehicle was produced before June 5th, 2009, with the 4-bolt pattern, thrust washer is required. And if your car was produced after that date, no thrust washer is needed. And if you're replacing a 5-bolt pattern, this is the new replacement part. So I have the new phaser temporarily installed. And this is a GM phaser. You can also get them at Cloyes. Now if you buy them separately at Cloyes, the bolt is not pictured. But if you buy the entire kit from Cloyes, then they supply the bolt. GM does not supply a bolt. They're a little difficult to find. What I'm comparing is this gap behind here, which I'll get a close-up in a minute. Here's the thrust washer. It's snug. Slides up and down on this one. So we'll talk about cam walk, which is also referred to as cam end play. Here's the gap I'm talking about, and what I've done is pounded the cam back lightly, and it moves very little. And with the small screwdriver, get right in that gap and push it. Hear that little click? That's how much the cam moved. Very little. And now I'll push it back. Can't even really see it. So there's very little cam walk. They have other thrust washers on the cam that doesn't allow it to walk as well. But I don't like the idea that this one is going to be snug. There's the movement. Very little. Now if you put a thrust washer in there and it's tight, I would think it would wear it out rather quickly. Or wear out the body, I'm not sure. Okay, so we're in the out position. Here's the thrust washer. It just makes it lightly. So I guess it just keeps it from walking. Now, that's very little walk. But if the car was running and this thing was walking just that ever little bit, it would prematurely wear the chain out. I don't like it. Another aspect I didn't consider is I believe these thrust washers are made of a softer material so they will not damage the adjacent parts, and they will be submerged in oil, so there'll be very little wear. So here's the thrust washer. I'm putting the raised edge towards the back. Not sure if that's how it goes, but no one told me any different. Then we have the phaser with the L on it, which is the driver's side, bank 2. Here's our dot, highlighted on the chain. Line that tooth with the dot on the chain. There we go. And it should line right up. Yep, it locked in. There's a pin back there that slides into the slot on the cam. And if you didn't move that at all, it just lines right back up. But you can always move that a little bit if you need to. Then get the bolt. Now I spoke to Cloyes online on one of their videos and asked, is this a torque to yield bolt? They said no, it's a standard bolt. You can reuse it, but they suggest getting a new one. And I'll put a link in the description where you can go and look in the comment section of that discussion. Snug that up. Then we'll do this one, and then we'll do the torque sequence. So once again, from circle dot to circle dot, you should have 12 links, including the colored link. Also recheck the timing down below, just to make sure. Now this is the exhaust side. They're the same on either side. Here's the pin that lines up with the slot right there. Colored link. Center of the tooth. There it goes. Right there. Now we'll check the gap. Here's a thrust washer for the other side. See? So they're snugged up in there a little bit. And now let's check the walk. Wow, very little. Hardly any there. That's excellent. So I've rechecked the timing marks and down at the crank. Flats are up on the cam. At this point, I can remove this clamp, put tension back on. So here's the squared area of the camshaft that you put your wrench on. And since I'll be torquing this way, you want to turn that wrench around to get maximum bite. Then we'll torque 43 foot-pounds. Now you notice I left all the oil on the bolt. I don't want to get technical, but that actually makes your torque more precise because it's less friction here and on the threads. Another thing I'm going to consider, provided the engine runs well, is after several heating and cooling, I'll pull these valve covers off and retorque them bolts. A little extra peace of mind. So here's the one I just took off, and I'm going to open it up to see if the exhaust is any different than the intake. And here's the setup that I'm using. It's not the best. A little loose. Probably should go to a vise. I don't think that's the right size because it's not fitting in there very well. But that's the only size that comes close in that set. Wow! There you go. Stripped out. When I said this is a 27, don't use it, guys. It's stripping them all out. And I am not going to spend the time chiseling. Maybe I'll check on the other side. Maybe I'll check another one later. But at this point, it seems like it's going to be useless unless I have the right tool. So now I'll do the exact thing on the other side. So to remove these phasers, we need to crank the engine to stage 2 timing, which is about 8 o'clock on the oil pump and the crank. You can reference my other videos on time and chaining gear replacement. The flats will be up on your cams as a reference. Now the use of a mirror and a light, you can see the dots right there. So I just noticed, since this tensioner is installed, the circle timing mark is almost obscured by the plastic here. So the timing mark is right there, and then you have one on the crank. Line them up, flats will be up, ready to remove these two phasers. And on the passenger side, they use the triangular marks in reference with the R, which is also 12 links from here to there. Okay, this tensioner is not pulling in, just what I do now. So what I'll do is I'll remove this side, which will loosen the chain, and then I'll reset that tensioner so I don't have to remove these bolts and break that seal. So I'm going to put a rubber band on this, remove the pin, and then we'll reset this part here. So I've got a clean glove with some grippies, and you just push down and turn the pin at the same time until it locks in. There it is, locked. Now we can put it back in the cylinder. So the spring end goes in, get a little oil on there, and then this side has a notch, which lines up with a little notch here in the tensioner. So when you put it in, you want to keep that notch lined up. And it might be a little bit springy in the beginning, but you're pushing the oil back into the engine and air, probably some air in there, and eventually it will stay in there for you. Yeah, that's good. Thrust washer, exhaust, and on the passenger side we use the triangle, and see, it goes right back in place on that cam down there, on the gear down there. Line up your dots. And now the chain should be loose enough to line up on that cam. There it went. I was too high in the beginning, but we're right in time down there. And I checked the walk on this side cams. Here's the walk. And it was the same on that one before I took it off. Oh, got it backwards. Who knows? Timing dot. Center of the tooth. Right on. Intake, R, passenger side, bank 1. Timing marks, 12 links. Check your links down there. And to re-engage this, all you do is push this down and it will engage. Okay, it's not engaging. I'm not sure why. I'm going to release this. Now there should be plenty of room to engage that pin with the screwdriver. All right. Now it's working. Now, I'll put tension on there and we'll be back to square one. Loose enough to put this back in place. Right there. Beautiful. Finally. All right, now I'll crank the engine over by hand. Make sure everything's kosher. Got some clicking going on, just like it did with the old phasers. Now I'll turn it over using the starter. So I'd like to point out some other areas of diagnosis before I went to the cam phasers. In the very beginning, the code said I had low fuel pressure, and I was influenced by friends and family and codes. Everyone saying change that fuel pump, but I was reluctant to do so because I had a rattle in the front. Here's the theory. Low fuel pressure, yes, will throw a fuel pump code, would also cause multiple misfires, but how would low fuel pressure cause rattle in the front? That threw me off. But I took a shot in the dark and changed a high pressure fuel pump, and the performance of the engine did not improve. That's what led me here. Now that I have a better understanding of the mechanics of the engine, this cam here has an extra lobe on the back that runs that high pressure fuel pump. Only on the direct injection engines have that feature. And if these cams are out of time, then this is firing that fuel pump out of sequence, which would cause poor engine performance. So yes, there's multiple things going on here. The engine's out of time for firing sequence, fuel pump is not firing at the right time, so it's going to run erratic. And that's what it was doing, plus rattling, because this was free and loose to do whatever it wanted. Another test I performed was a compression check to determine if I had bent valves, and majority of the cylinders was exceeding 200 psi. Originally, in the other video when I did the timing chain and gear 6 months ago, I did a compression check and the majority were at 180. It's a mystery to me. So one of the things that stuck with me through this whole process is the initial problem. What caused that fuse to blow that runs the ECM? Is there a problem with the ECM? So I did an electrical diagnostics of the cam sensor plugs, testing for correct voltage. That was good. I did an ohms check on all the sensors. There's 3 prongs in here, and I'm touching the 2 outer ones. I tested the actuators, solenoid, these are all working properly, and you see they're not sluggish, means they're clean. So I'll provide a separate video for that process. But hopefully this will take care of the issue, and if I start the car and it purrs like a kitten, I will be shocked. And if it doesn't, I'll dig deeper. I'll provide a link in the description for reassemble. All reassembled. I removed the drain plug and drained that milky oil. With that said, I'm going to get into the vehicle, press the accelerator to the floor. That will disable the fuel circuitry. Crank the engine, build oil pressure, release the pedal, and it should purr like a kitten. So it's improved a little bit. I just got a code P0300, multiple misfire, and it's misfiring on cylinder 2 and 5. So I'll look at the coil packs and spark plug. So the coil packs and plugs checked out good. So while it was running, I decided to remove the connector for the cam actuators, all 4 of them, and now it purrs like a kitten. So I'm getting a little rolling effect, but if I plug the actuator in, it runs worse. So I heard a little click when I plugged that in, which means the solenoid engaged. It is working, and it was delivering oil to the variable timing. So either I'm getting a bad signal from the ECM or I need to replace these cam actuators. Another thing I'm considering, if those cam actuators are activated, that's allowing oil pressure to go to the locking pin on the cams, and there's a good chance when you turn the engine off, the cam is unlocked and stops in the wrong position, which is creating a rattle at startup and poor engine performance. Another discovery, just out of curiosity, with the key ignition to the on position, the solenoid is activated. These 2 solenoids activate as well. However, this bottom one, which I think is the exhaust, does not activate. So now that puts us in a whole different direction. And when I originally tested these plugs, I tested the red wire, figuring that was hot, and it was. Put a meter on here to ground and got 12 volts. Never checked the other side. And I believe that's the signal wire. Also a ground, where the ECM sends a pulse on the ground. And we'll check and see the difference between this plug and the others. Okay, I got the meter on ground, set the DC volts, checking the red wire, 12 volts, bottom one, 12 volts. Now we'll check the signal wire, 2.0, basically 0. And that reading is the same reading I get on those two. So now I'll start the engine and watch the signal. That was at 2,000 RPM. Quite a difference in reading. So those other two had readings the same as this plug. This is the only one that fluctuates and seems to be working correctly. And I didn't show this on film because you couldn't hear it, but I revved it up and engaged it on here. And when it was at 2,000 RPMs, it engaged this solenoid, which seems to be proper. Why would you want to engage at idle? Why would you want the pin unlocked at idle? So this one, when it's plugged in, doesn't affect the running of the engine. It still runs good. So I would say this is how the other three should perform. So maybe I have a short in the wire system, a bad ECM. I don't know everything. I'm still shooting in the dark. And that's the way it goes when you don't have a scope and the knowledge to go behind it. You just keep digging and digging, seeking, and ye shall find. So I'm thinking about doing a continuity test from the signal wire and then find it here on the ECM, on the pins. And then maybe I could test the output from the ECM. That sounds difficult, but maybe I could find the wire, inspect it, because it has to be hooked up and back probe. And I've never done that before. I mean, this is pretty... You know what? Since this is taking me in a whole different direction, I need to wrap this video up, because the bulk of this video is about cam phaser replacement, and allow this video to serve as cam replacement. And hopefully in the next video, I'll have the solution, I'll show the diagnostics, and since this video will be available, perhaps someone that has experienced this same issue can give me the solution in the comments, or things to try. I'd like to thank everyone for watching. Hope this has helped someone, and I'll see you in the next video.